Hey guys, I'm Jack McDonald. I'm a 15-year-old innovator with the Knowledge Society, and right now I'm super psyched about AI and its applications in the world. In this video, I'd like to give a brief description of the fundamentals of reinforcement learning and kind of explain some basic concepts that really allow computers to see. And then I'd just like to tell you a little bit about some of my projects and just kind of summarize what I've learned. Okay, so first off, what is computer vision? I know when you think of vision, that latter part of the definition really kind of points to something larger. Let's just first think about what you and I can decipher as vision. So, when we walk into a visual scene, we glance our eyes to different features, or what they formerly called, different characteristics of, the table in front of you, the food you're about to put in your mouth. But you can't decipher the meaning of a digital scene or a visual scene from one look, right? And this is how computers think in somewhat of a simple sense. But they do this kind of smaller, broken down analysis through what's called pixel isolation. And so what computers can do is break down a photo into a desired pixel dimension. So, for instance, in this photo here, we see a man on a bike with flowers in a city surrounded by cars and buildings, right? Pretty simple. We can decipher this relatively easily just because we've been trained on kind of our large knowledge base. But once again, computers obviously cannot do this as it is quite difficult just by looking at the simple photo. However, they can break this photo down into a desired pixelated dimension and then break down and analyze each pixel accordingly. So something like that would look a little bit like this. And the pixel dimensions can vary. For many very basic photos, it usually could be a 28 by 28 pixel grid. And so what these do, especially for things like black and white images, like something like this, and especially with black and white, the computer is able to decipher and analyze specific pixel value. So say if something's black, that pixel value, or that initial neuron in a neural network, would hold a value of 0. If it's white, like the S, that might hold a value of 1. And so depending on these pixel values, the computer would be able to pick up on some patterns in these values and essentially predict where, I guess, the more white spots would be on this particular part right here, on any of these given letters. And for this, it would be slightly more difficult. And that's where more advanced machine learning and computer vision algorithms come in. Just recently, actually, some breakthroughs have been kind of made in this space with the development of an algorithm called YOLO, You Only Look Once. And so what this does, instead of kind of brute forcing an analysis of a photo by analyzing each individual pixel and curating value, it looks at it once, and it's already pixelated. You see, it already breaks it down into individual pixel analysis. However, it will understand patterns within those pixels, this large-scale pixel value, and you can see here in the coloration pattern, it will pick up general similarities there, and then using another form of analysis up top, you can overlay these two to get a quite accurate depiction of where the objects would be in a visual scene, right? And that's kind of how more complex images are analyzed and objects categorized. And obviously, depending on what the data set being trained is, you're going to be able to understand kind of what certain objects are. So, for instance, in this example, it might be fairly obvious that this is a car, a dog, and a bike. And obviously that data set might be somewhat more generalized, but for medical uses, for computer vision medical uses, they might be trained on a medical data set using, I don't know, scalpels, medical incision patterns to understand that. So I think just understanding that concept is really key to understanding how widespread the application of computer vision could be. And I'm really super excited about the future of the technology. To practice these skills, I've coded a number of things. Two kind of hello world projects, if you really like computer vision. And they're brought by the MNIST data set, which is really super awesome because it's such large pools of data that you can manipulate and analyze to your liking. So the original is the handwritten digit data set. And that's probably, again, that's the hello world because it's much easier to assign pixel value if something's either black or white, of which the handwritten digits are. And so it's definitely interesting, and it's very insightful if you're just trying to get into it. And I'll leave a link in the description for that. But the second is the fashion MNIST data set. That's really cool, and it's definitely a step up from the handwritten digits. I actually used that as a project of mine, and it's really awesome. It definitely gets you thinking about the possibilities in terms of array analyzation and analysis. But it's definitely very interesting, and obviously you have to use Python, or at least I did. There may be alternatives, but I don't believe so. Python's obviously the main machine learning and AI programming language. But yeah, and so I'd like to summarize a bit of what I was talking about in this video. To begin, computers can't see by just understanding generally a visual scene. They have to break that down into a little bit more bite-sized pieces, if you will, by creating desired pixelated dimensions. From there, you can use a variety of algorithms to analyze those specific pixelated value patterns. And then, depending on what data set you're training your algorithm on, you can detect certain objects with some identification, depending on those patterns. And you can use this primarily through convolutional neural network code. And you just pick up on patterns depending on each network, or rather layer. But yeah, I'd like to end this video by thanking you all for watching. I'd leave my social links in the description, and if any of you guys have any problems with the content, definitely feel free to reach out and inform me. Always looking to learn more. Thank you.